Today I want to focus in on the intermediate value theorem. We can also abbreviate this as the IVT. The intermediate value theorem states that if f is a continuous function on a closed interval from a to b, and k is any number between f of a and f of b, then there exists at least one number c in between that or on that interval a to b such that f of c equals k. What on earth does that mean? Let's come back and draw a picture so we can kind of see what this kind of looks like. So the first part of that says f is continuous. So we have a continuous function. So nice continuous function there. On a closed interval from a to b. So we can put a here and we can put b down here. All right, so then there's going to exists a k is between f of a and f of b. Well, f of a, if we come up here, there's going to be f of a. F of b, if we come up and come over, there's our f of b. So there's our f of a, here's our f of b. So k is between f of a and f of b. So we'll call k there. Then there's going to be value c that's going to exist on that interval a to b such that f of c equals k. So if I work my way backwards, then my c value would be in there. So c would equal, or f of c would equal my k value. So why is that important? Well, we know then that if we know f of a and we know f of b, and this is a continuous function, then we know that c, if c is between a and b here, then f of c is going to be between, or if k is here, then if f of c is between f of a and f of b, then c has to be between a and b. Kind of work my way backwards there. So why do we use that? Well, we use this generally to find the existence of a zero, but we can show that there's going to be any existence of any value. So say that f of a is or a is 2 and a b is 10. And we know that f of a was, we'll say, 7 and f of b was 20. So we know then that there would exist a value between 7 and 20 on this interval, and there's a c that's in between a and b. Might make a little more sense if we look at a couple of examples on how this is useful. So in example 1, it says verify there exists a value c guaranteed by the IVT, the intermediate value theorem, for the function, and then find the c value. So here f of x equals x to the third plus x on -1 to 1, and we will know, is there a c value such that the function equals 0? So what do we do? Well, we're going to find the value of f of -1. If I take f of -1 and plug it in, I get -1 to the third plus a -1. -1 to the third is -1 minus 1. That gives us a -4. If we have f of 1, the b value there, I get 1 to the third plus 1, which gives us 4. So I know that there has to exist an f of c so that we get a 0, because f of -1 is -4 and f of 1 was 4. We know that 0 is going to lie between -4 and 4. So by the IVT, we know this has to exist. So how do we find that? Well, what we're going to do is we're going to take x to the third plus x and set it equal to 0. We're going to go ahead and solve for x. We can factor out an x. So we end up with x equal to 0 and x squared plus 1 equals 0. We know x squared plus 1, if we solve that, x squared equals a -1. That can't happen. So we can just get x equal to 0. So we know that the c value is going to be 0 as well. So we know by the IVT that there's going to exist a 0 between -1 and 1 because the values were -4 and 4. So we know here at -1, we were down here at -4, and here at 1, we're up here at 4. So we know if it's a continuous function, this function has to go through 0 somewhere between these 2 points. It could go through a million times if we don't necessarily know what the function looks like. But we know there's at least one value that there's going to be a 0. And we found that here at x equals 0. Again, we can do this for any value. It doesn't necessarily have to be the existence of a 0. So we can show, in this example, x to the third minus x squared plus x minus 2 on the interval from 0 to 3, that there exists a value that's such that it equals 4. So if I plug in 0 here, f of 0 gives me -2. F of 3, here I get 27 minus 9, 18, plus 3 is 21, minus 2 gives me 19. So since f of 0 equals -2 and f of 3 equals 19, and I know that 4 is in between there, somewhere in between there, I know there has to be f of something to give me a 4. And that something has to be between 0 and 3. How do I find that? Well, I can go ahead and take my function and set it equal to 4. So I get x to the third minus x squared plus x minus 2 equals a -4. Or equals 4, sorry. I'm going to subtract 4 over. So I get x to the third minus x squared plus x minus 6 equal to 0. How do we solve that? Well, we could use our p's and q's. Remember, our p is our -6, q is 1. We take all the factors of -6, divide by all the factors of 1, and we go ahead and find a 0 of it. At this point, though, I would suggest pulling out our calculator and putting it into our calculator to find that 0. So I've already got my calculator in there. I'm going to do the second calc. I'm going to find my 0. I know my lower bound has got to be 3. My upper bound's got to be, my lower bound's got to be 0. Upper bound's got to be 3. So that's going to give us an x value of 2. So we know that f of 2 is going to equal 4. Now, you may be saying to yourself, well, I have a calculator. Why don't I just throw it in the calculator and be done with it? And if we have a calculator available to us, we can. But what we're going to see is that we're not necessarily always going to give an equation that we can throw into our calculator. So example 3 is very much an AP style question that can be asked. In example 3, they're giving us a table. We have time here. We have 0, 1, 2, 3, 4, and 5. And we have f of t, so the values of those are 3, 5, 9, 4, 6, and 0, or that would be the position there. So it tells us that a particle moves along the x-axis continuously. And the position of the particle at certain times t is given in a table as f of t. Well, what does that mean? Oh. That means at time 0, we are at 3. Oh, put that in the wrong place. So out here at 3, this is t equals 0. At time 1, we are at 5. So we come over here to 5, and we're at t equals 1. So we start here at 3, we go to 5. We end at 5. We don't know necessarily what happened between times 0 and 1. We just know that we went from 3 to 5, so we can put that in there general. At time 2, we're out here at 9. So we'll put a 9 there, we're at time 2. And this is just very linear at this point because we don't necessarily know what's happening in between there. At time 3, we're at 4. So maybe we came up and came back here to 4. Now we're at time 3. We went back to 6. And that's at time 4. And then at time 5, something happens. and we end up at 0. So we know that we started at 3, we went to 9. We could have gone farther. We don't know what happened between time 1 and 2. But in general, we came up, we came back, we went back, and we went back farther. So is the particle, will the particle ever return to its initial position? And we want to justify that reasoning. So how do we justify it, and how do we show that it's going to return to its initial position? Well, if we look here, we went from 3 to 9 to 4 to 6 back to 0. When we went from 6 to 0, we had to cross that 3. So for a split moment in time, we had to be at that initial position. So our justification would be, or our answer would be, yes, the particle will return to the value it initially started. And then our justification would be because f of 0 equals 3, and we know that f of 2 was 9, and f of 5 was 0. We could have done this with a lot of different things, but I know that we started at 3 at time 0. We know that f of 2 was 9, and f of 5 was 0. So since f of 2, I didn't put that in there, f of 2 was 9, and f of 5 was 0, by the IVT, there must exist a value between f of 2 and f of 5 such that f of x equals 3. So that takes care of our explanation on why that has to happen. Again, we could have used any values. We could have used 3 and 5 because 3 was 4 and 5 was 0, and we're only looking to see that we get that position of 3 in between it. So that would work. Also 4 to 5 would work because we go from 6 to 0 as well. So you could down here put f of 4 was 6 and f of 5 was 0, so we know there had to be a value of 3 in between there by the IVT. So a little bit of wiggle room on your justification as long as you have one of the values higher than what you're looking for and one of the values lower than the point that you're looking for. And that's going to go ahead and take care of our IVT for the day.